Good morning, guys. We're going to go ahead and get started sharp at 10. I'm Mike.
I'm Brandon.
And how many people in this room have any tuning experience at all? Are there a lot of tuners in the room? Okay, great. We've got a presentation lined out. We've got time for questions during the presentation, so if anybody has any questions, please stop and ask. I don't see too many familiar faces in the room, so if you guys have any direct questions after the seminar, we'll be in our booth. Obviously, come by and say hi. But we're going to go through this. Is anybody interested in Global B? We have some. Okay. All right. Yeah, we weren't really sure. We're going to kind of read the room here. So we've got some Global B stuff. We'll probably go into towards the end and give you guys a look at, say, the neural network trainer and some of those ideas that Brandon's going to go over for you guys. So we're going to go ahead and get started.
Mr. Toon, how are you?
Look at this. Tony Gannon in the room.
Morning, gentlemen.
This guy.
So just to kick it off here, guys, let's talk about who we are. We're not really two guys that like to beat our chest and talk about all the stuff that we do, but between Mike and I, we've got over 25 years of experience in the industry, and Mike and I were the head calibrators at Vengeance Racing for quite a few years, which is really where we met. And as we've been tuning cars over the course of years and years, we figured a lot of guys are at a real disadvantage with some of the top trade secrets in the industry, and nobody wanting to relinquish those. So we came up with the idea of making a school that it takes all these complicated things and really breaks it down for most people to understand.
So he just went over who we are. But like Brandon said, our whole goal, this is our college program here at UNOH, but our whole goal with the school itself was to take pretty much the top level guys that we could possibly find on the planet, build a school that actually relinquishes every single secret, trick, nook and cranny to make a level playing field for the entire industry. So we're trying to do that with every single make, model, and everything. We've got a lot of stuff coming out next year, but we're kind of known in this LTX world and Global B stuff, so that's where we're going. HP tuners, I'm sure everybody in this room knows who that is. We only have one slide on this, but we didn't know who was going to be in the room. But Tony Gannon's here if you have any questions about HP tuners. He's your man on your devices and your software, and that's primarily what we teach on in our system, and we think it's the leading software in this market and in this industry.
So Gen 5 came out roughly in 2014, and a lot of you guys, if you spent some time with GM Gen 3, Gen 4, and also into Gen 5, we're going to start talking about the key differences between the drastic differences between Gen 4 and when we moved into the Gen 5 areas. So what are the main differences between Gen 4 and Gen 4, Gen 3, Gen 4, and Gen 5? So the biggest difference between them is we went from port injection to direct injection. And we also went from a predominant airflow-based model to a full torque-based model. So Gen 4, we started implementing some of the torque-based strategies, but it was still predominantly airflow-based. We told the vehicle how much air we needed to idle, etc. Where when we moved into Gen 5, we're going to be predominantly torque-based, and we needed to have a better understanding about the torque model to get these cars to idle and drive correctly. And that's predominantly the main differences between the two.
And when we got into direct injection, we started running into high side fuel pumps, different styles of injectors. Injectors obviously changed. Now we only have 5 or 6 injectors versus the 50 or 60 that are out there, and the fueling methodology changes a lot when you switch over from one to the other.
So port injection, we had a low side pump, and we had port injectors. Now when we move into direct injection, we still have a low pressure fuel pump, but now we've added a little bit more of a complex system where we actually have a high pressure pump that is driven by our camshaft. So in the back of the cam, we've got a load that drives this thing, and now we've got the addition of injectors in our combustion chamber. So the main difference that you're going to run into with a lot of these direct injection stuff is our injection window. We've got substantially less time, usually less than roughly 6 milliseconds to get the fuel in versus say 20 plus milliseconds that we had with port injection in years past.
And here's the keys to the kingdom when it comes to these cars, and that is the virtual torque. Understanding how to use these will not only help you, it's the only way to tune and to get the idle correct, to get your transmission to shift correctly. And although we did play a lot with these on the Gen 4 stuff, when I say Gen 4, E67 and 38 stuff, this became detrimental. It became clear as day that if you did not fully understand how to work this, the car was never going to be correct. You could hack your way through it, and the car might run and drive, but you can make these cars run absolutely perfect just by understanding this one table.
Well, and one of the other things is, early on, when we were starting to implement camshafts and things like that into Gen 5, one of the big common problems that everybody ran into is, hey, my timing's negative, the blade's open too far, I can't get this thing to idle with any positive timing. Well, once we started to understand how all this stuff works, it always came down to we had to reconfigure our torque model to get everything to operate correctly. So idle, drivability, wide open throttle, this is the key to the kingdom, to understanding how to make these Gen 5 vehicles and Global B operate the way we need them to.
And we cover this extensively in our courses, because this is, like you just said, it's the keys to the kingdom. If you can understand that fueling system and how to balance the fuel, and you can understand the torque system, everything else is pretty much going to translate over, minus setting up your knock sensors correctly and everything else.
So fuel system overview. So one of the biggest things that, especially in the aftermarket world, that you guys are going to run into when you start really pushing these torque-based ECUs is fueling problems. So as I mentioned previously, with port injection, we kind of had a significantly wider window to get our fueling in. With direct injection, especially with the added complexity of a lot of these guys wanting to make more and more and more power, we've got aftermarket injectors, aftermarket high pressure pumps. The biggest issue we were starting to run into, when we start getting up in these 800, 900, 1,000 plus horsepower Gen 5 vehicles, is balancing fuel systems. So understanding that there's a couple key critical points that we need to start to be aware of, which is start of injection and end of injection timing. And once you really understand these two critical pieces, then we could start to understand, the maximum window we had to get fueling in to make efficient power. But you can also quickly get on the other side of this where we're misfiring, we're having problems, we're draining the pump, the injector pulse width is going through the roof. So really understanding, how to monitor low side pressure and high side pressure, what's our desired versus our actual, and balancing these two is really going to be one of the critical components to Gen 5 tuning.
And as you get into, a lot of people now are obviously using the 85, and pushing these fuel systems becomes one of the real key elements into making max power. If you can't understand the fuel system on the side, no matter what you do in the tune, the car's always going to roll over. It's never going to be right. And it also is going to affect your torque value. So setting up your fuel system correctly, will all obviously affect your airflow model to get the torque right.
We kind of breezed through that much quicker than I anticipated. How many people in here are really interested in Global B? Okay. All right, so we're going to, God bless. All right. So I'm going to spend the next 40 minutes or so going over Global B at this point.
Yeah, we didn't know what we had here, so we had a couple different ideas. But with so many people interested in Global B, we figured, we want you guys to get something out of this. So we're going to take this to Global B land. So if you feel like this is going to go way over your head, it might. But we want to introduce you to the concepts of Global B, and at least so you start to see it and understand it and realize that it's not black magic and it can't be done.
Before we move into Global B, does anybody have any pertinent questions or have, want anything on Gen 5 cleared up as far as, torque tuning or, fuel systems, start of injection, end of injection? Yes, sir.
In fact, What are the main sensors that the ECU takes in consideration while excuse me, I'm
No, that's okay, take your time.
while knowing which torque the engine is producing? Because I know it's torque-based, but
Mhm.
what are the sensors that how the ECU knows how much torque the engine is producing?
Airflow. Everything always comes down to airflow. So whether it's your volumetric efficiency table, math, combination of the two, whatever model that you decide to use, those values are always going to directly correlate to a torque output.
Okay, and what's in case of an engine stop, what's the base pressure you suggest to run the engine to?
When you say base pressure, are we talking high pressure?
No, low pressure.
Low pressure? So, I mean, it really depends. I mean, truthfully, you can run it wherever you want. Depending on the setup. Some of these bigger setups will, sometimes I'll run 90 plus PSI on the backside of that high pressure pump to keep it fed. So, but anything your 40, 50 PSI, low side of pressure is usually ample. And you'll have different modes. Obviously, you got high flow modes. You can command a different pressure, normal modes, hot fuel modes. All those are going to vary your fuel pressure.
Okay.
Yeah. Any other questions? Yes, sir.
I mean, even if you wanted to spend I'm sure a lot of us would appreciate just spending a few more minutes maybe talking about some of if you can reveal a little bit of strategy behind the torque.
That's why we're here.
Myself, I get the basics of it, you gotta get your VE model right, that's like the huge one, but like, I've yet to have someone show me a mathematical way to fill out that torque table versus it's like, well, if it seems a little high here, lower it, and it's just, I hate that. I tune with histograms and math, and spreadsheets.
I mean, I can run you guys through how I set up, a basic car, heads cam cars, all that stuff, if you wanted to take a few minutes to learn that. But yeah, that's why we're here. I mean, there's no secrets.
The torque's a big thing for me. The rest of it makes sense, but the torque stuff is, it makes sense, but I want to know how to mathematically figure it out.
Well, why don't we just go over some torque model itself, and say it's just a Gen 5, like a 06 or something, we'll grab some of that. We'll go through that, we'll go through some of the fuel system settings, and then on your question, most of the cars are set, you want to say 43, and they go high side, you say, 3 bar, which is 43 and a half, or run up to 58. But if you run 58 to the backside of that pump, you should be fine. And you're going to be able to log it anyway in your scanner, and you're going to see if it can drop and fall, which is fine. The question is what is the high side pump doing? Once that high side pump is not meeting the command of the request, that's when you're going to start to have problems. So the high side pump is what we're most concerned about. Obviously, the low side plays a factor, but to answer your question, if you can get 58 to the back of that pump, you should be fine for the most part.
Yeah, it's where when the low side pressure starts to fall off and we start to cavitate the high pressure pump and everything starts to fall off, that's when we start running into some major issues there.
How does changing the cam mode, saying that market cam for a bigger fuel on it, does that affect that?
It's actually smaller. Yeah, so you're basically increasing the stroke of the pump, which is where you're getting your additional fuel volume.
And that's why you got to put the cap, and hopefully you guys are putting the cap on and you're measuring and actually doing the homework. And you can't just slap these things together like back in the day where you just slap the cam in, dot to dot, and let it roll. You're definitely going to want to check that pump, because if you don't, you will pay the price, especially in the Lingenfelter pump.
Yeah, it becomes critical when you start doing these aftermarket cam loads and things like that. You need to measure fuel pump preload, make sure that's all within spec. Otherwise, you can start. You basically float the actual lifter itself. When you start getting into high RPM stuff, you'll start to see the fuel pressure start to walk away from the command, and it's actually rising. Some of that can be fixed in the tune with leading and trailing edge angles and things like that. But if you're literally starting to float that thing and you're getting some chatter there, you'll start to see some adverse effects of rising or fuel pressure running away from it. So it is critical to make sure that you accurately measure every install. And guys will have a combination of different ways of doing it. Some guys will mill the valley plate, 30 thousandths of an inch, and measure preload that way. Some guys will use lash caps. We've done it both ways. I mean, it all works either way. Yes, sir.
What all goes into the ECU calculating the max engine torque channel? There have been times where I've noticed that doesn't line up exactly with the virtual torque.
Sure.
So what tables plays in that.
So the max engine torque pay that you're referring to, in my experience, has come from the VE table. And truthfully, I don't pay as much attention to that anymore as I do some of the other, torque tables. So, one of the things that a lot of guys struggle with is I can't keep the throttle open, or a throttle's closed on me. I got a Pro Charger combo, I got a Maggie 2650 combo. The throttle's not staying open. And typically, it always starts in the driver demand table. How much am I requesting? How much torque am I requesting? Whether it's in, your automatics will be an axle torque, or your manuals will be in Newton meters, whatever it is. That's the request, so that's where we start. Now, there's checks and balances inside of the file. It's going to check it against a peak torque table. So if your peak torque table is not high enough, and you're requesting more, or the engine is making more than the peak torque is allowed to get to, you're going to run into a clip. If your request is higher than what's in your virtual torque table or your torque model, you can run into blade closures. There's really only a couple reasons why your blade would ever close. It's because you're not requesting enough. So if your request stays above what's in your virtual torque table, usually you're going to be fine. Now, there's additional things. If you've got a lot of guys will do Pro Charger kits and they don't break the baro sensor out, and you'll see the baro skyrocket through the pull. That'll close your blade. So it's critical to make sure all your sensors are working properly. So, if you're pressurizing the pipe, turbo cars, Century blower cars, you've got to break the baro pressure sensor out of there and make sure that that model stays accurate, because now you're going to change your pressure ratio tables and all that stuff too.
So do we need to tune the VE table over 4,000?
So this is the magic question that everybody asks. Can I tune a car math only? Can I tune it VE only? Speed density only? Can I blend the two? And the answer is I've done all three. I always encourage people to, especially if you're new to this, to me it's always best to get all your models accurately modeled together. But yeah, at the end of the day, what was your? I'm hoping I'm answering it correctly.
The VE cable is disabled above 4,000.
It's like a 4,000.
On that stock file, but if the virtual torque is referencing the VE cable over 4,000, we need to tune the VE cable.
So the switch point of that is not, so the torque numbers are going to be derived from both models if you're using both models. So the virtual torque, I'm trying to figure out how to answer that correctly, or answer your
So
question.
I think I'm assuming, right? You're wondering if it's switching over at 4,000 RPMs,
Back to back.
are you having a torque changeover
Yes,
over to
the
the?
VE cable
the-
above 4,000.
Well, that's where you log dynamic interface. So dynamic is going to tell you which one it's referencing. Am I referencing more of the VE side, or am I referencing more of the MAF side? So above 4,000, in theory, it's going to reference more of the MAF. So your dynamic should follow very closely to the mass airflow sensor.
And we teach it both ways. So, in our courses, we teach you obviously how to build out the VE tables, which you guys are probably somewhat comfortable with. But you can also, the MAF sensors on these cars are, light years ahead of, say, the Gen 3 MAF. So you can MAF tune on these cars and very, very well. I think Jason Lieber's car still has a MAF on it. That holds a world record.
Yeah, and again, that's the question everybody always asks is one model okay over the other? The record-setting 6-gen Z01 right now that just ran 780s at 177 with a factory 10-speed, that is tuned in MAF only. Starts up fine, drives fine, runs fine, goes down the track fine, but I've done it both ways. I've speed density tuned the car because it's got a gigantic 6-inch bell mouth on it, but it really didn't make a hell of beans of difference which way I did it.
So, it's always do your own research, right? So run it both ways. Obviously, we come from a theory of, Gen 3, Gen 4, where you have to speed density tune these bigger combos. It gets a little different with Gen 5 because you have more control. You have more control of your fuel. The sensors are better, they're faster. But do it both ways, and see what works best for you. But I think in the end, you'll find that the method that we teach will take you all the way to the sevens, if need be. So.
Yeah, and that's the other thing is the big difference between us and some of the other stuff out there is we help you guys understand the stuff that we do day in and day out. We tune 15 to 20 cars a week, and predominantly it's mostly Gen 5 and Global B. So all the stuff that we're going to show you guys is stuff that we know definitively works. And in the aftermarket world, we're blurring the lines of what is correct between an OE calibration. I see Greg in the back room, I think. You know, so what is correct from an OE standpoint? What do we need to blend as far as making stuff work in the aftermarket world?
Any other questions? Very good.
Yeah. My first question was, in fact, what sensor is mandatory? So, as I understand, you don't have to have a map sensor to get these running, but do you need a DSS?
Did you say a MAP sensor? You definitely need a MAP sensor.
Do you need a map sensor?
You 100%.
Even if you are map only?
Correct. Because there's still tables that are even if you're MAP only, there's still tables that are reference.
Because I
Startup.
had a big problem on the dyno with the Gen 5.
Mhm.
The tuner, I'm not a tuner in fact. The tuner tried to tune it map only,
Mhm.
so we didn't have the right map sensors hooked to the car, so I just unplugged it. But you said you needed it.
The car will run without it in MAF only. It's just probably not going to start real well, and you might have some weird issues going on there.
Yeah.
I've had them shut the injectors down on you midway through if the map goes to 0.
The throttle was shutting, and we don't have any speed sensor either.
Speed sensor is going to be critical too.
Yeah.
Yeah, and that's your adaptive idle strategy is probably not going to be real happy there.
The ECU was a 2014,
Mhm.
and the car was mated to E56.
Yep.
Two-wire speed sensors. I tried to hook it up as according to the
Diagram.
diagram. Excuse me. And it didn't work.
So-
The VSS was jammed at
158.
Yeah.
So the trick to that is, like when we do power glide conversions or turbo 400s on like 6 Gen ZL1s, I will actually go and set the speed sensor to no sensor, and it'll actually convert it to the ABS sensors. So if you start working ABS sensors, that'll fix that problem.
I don't have ABS sensors. It's a 71 Camaro.
Okay. Yeah, you're going to have a speed sensor of some sort, or you're probably going to have throttle issues, you're going to have adaptive idle issues. It's probably not going to do what you want it to do.
Because as the man was saying, the torque of the dyno doesn't match the torque value in the ECU. I've skyrocketed the torque value, and the throttle was still shutting down. If I go to I, the car sits in storage value.
Mhm.
The car enrichment didn't came on, so it was 14.5 all the way.
Swaps are going to be very difficult if all your critical sensors are not together. I've run into this many times.
But the map sensor, I mean, there's no way you're going to get by this without the map sensor. So I would start with the map sensor for sure.
Yeah, you've got to have a working speedometer to really to make this thing operate the way you want it to, or you're going to be fighting an uphill battle. But here's the other thing too. You mentioned you made the torque really high.
Yeah.
Well, if you make the torque higher than what you're requesting, it's going to shut the throttle too. So if your virtual torque is skyrocketed high, but your driver demand is lower than the virtual torque, you're going to run into a throttle closure. So you really want to go the opposite. I mean, I get what you're trying to do. It sounds like you're trying to match your torque to whatever it's making on the dyno, which isn't wrong. I mean, it's always, if your airflow model is correct, your injector data is correct, your torque value should kind of fall in line with what it's making, so to speak.
It's complicated.
Oh, they can be.
We'll
They can fight back.
pull it up on a Zoom file here in just a second.
Do you have a question?
Yeah, so with all the aftermarket drive-by-wire stuff and Gen 5 stuff getting, swaps getting more relevant, from what I'm seeing in my area, chasing the external load table with any idle issues and stuff, what strategies are you all doing? Because usually if I remember serving rights, looking to like an oil temp, and that table at records usually defaults at like a negative 140, and so I normally have one column, and I'm not able to interpolate or cleanse in a swap vehicle. What are you all doing to mitigate the sending idle issues?
That's a phenomenal question. I almost feel like we need to pull a tune up here and walk through some of this stuff.
Yeah, let's go ahead and just get a file open, and we'll start going over some LT stuff.
So to answer your question, I rarely actually use the external load table, and I'll show you kind of my strategy on how I get stuff to idle. Again, there's 5 different ways you can get these things to do what you want them to do. I'm going to share with you my experience on how I get every Gen 5 car to idle correctly. This is probably going to be really challenging to do with a microphone in my hand, so.
I can turn that on.
What's that?
I can turn on voting mic.
Okay. Yeah, can we turn this one?
Yeah. Or you can swap it on.
Hello?
I'll mute it.
All right, can you hear me? So I'm assuming you're talking about when you add a camshaft.
Right.
Okay, so here's my general consensus on how I will go ahead and get something, a base file up and running. So again, there's 10 different ways you can do this. This is the method that has always worked best for me. So this is a torque model of the entire ECU based on timing advance and cylinder air mass, essentially, right? So from experience, if you log a stock truck, where do they idle as far as cylinder air mass? It's usually 0.16, 0.18, somewhere in that ballpark, right? We've got a pretty efficient cam. When we add a bigger or larger or more, or camshaft with more overlap, what tends to happen to our cylinder air mass? It's going to go up, right? Now, let's say we want to idle. I mean, where do we want to idle? Between 10 and 15 degrees of timing, usually on these things? It's a good spot, right? So, at 10 to, you've got all these, I'm assuming you understand the air mass table. So air mass is usually going to equate to pump gas. If you're on E85, you've got 85 air masses, you got to worry about too. Well, let's just say we're on pump gas. So look at what happens with our idle torque, give or take, between 700 and 950 RPM. If we're idling at 0.16, where do you think our idle torque is approximately going to be? 30. Well, you got negative 30 in one column, and you got 18, well, you got negative 19 in this column, you got 40. So we're going to be somewhere around 10 to 15 pound-feet of torque, give or take, right? Well, if we do nothing and we shove a camshaft in one of these, what happens to our torque? It goes way up, right? What do you think we're going to have to do when we add a camshaft? Yeah, lower the torque, right? So my typical approach is I want to idle around 0 to 5 pound-feet of torque at idle. So I will slowly come in here and I'm going to reduce these numbers to somewhere around 0.2 cell air, because I know I'm going to idle in this ballpark, and I'm simply just going to blend between these. And I'm going to extrapolate the coefficients, calculate. Now, if I get all my other stuff right, airflow model is all correct, trims are in line, because remember, you don't want to really, this is just to get this thing up and running. If your airflow model is way out left field, your cylinder air mass is going to be artificially high or artificially low. You've got to get your trims back in line before you come back in here and dial this in. Otherwise, you're just going to take your tail. But this is how I usually get one to start up and do what I want it to do. From there, you've obviously got your base set point. You want to make sure that's right. You want to make sure your rolling and moving idle is set up. Guys miss this all the time. That 0 column can override some other things. So get all of this set up right. Let's say 750, 800 RPM. Your startup tables are going to be obviously set up correctly. So now that we have those tables set up correctly, you don't need to come into this adaptive idle, jack this through the roof, which I see guys do. And we've got this additional torque tab. And this is kind of what you're talking about. External load, and we've got a speed control reserve. I see guys that will come in here and this thing will go through the roof. I don't really touch this table unless I have to. So I look at this table as timing. If I raise this table up, I can end up reducing my timing. If I lower this table, I can increase my timing a bit. So if I get everything right, I verify I have no vacuum leaks, and I'm idling at 2 to 5 degrees of spark, torque looks good, everything looks good, I've done a throttle clean, and everything, it's just not quite, I don't have the timing I want. Sometimes I'll come in here, I'll actually start reducing this table in small increments until my timing comes up to that 10 to 15 degree range. Now,
So if you're saying 0, and you're saying negative timing, you'll reduce that.
so the negative timing is typically going to come from your torque model being way too, if your idle engine torque is 60, 70, 80 pound-feet, you're usually going to have, what does torque usually equate to? It's going to open the throttle body. So that's why your throttle body is going to be at 25%, sitting TPS at idle, your spark's at negative 10. But when we reduce the torque in the virtual torque model, we're going to lower the blade and it's going to increase the timing. So that should get you in the ballpark. Now from here, I will use the speed control reserve cable to kind of fine tune my spark. And realistically, over thousands of cars, that has 100% got me to my desired result.
And if all that fails, the throttle clean, which you did mention, if you have everything in line, we've saved several high-level professional tuners with that throttle clean feature. So you want to look at that in your scanner and possibly use that throttle clean.
Yeah, I mean, I do use the external load tables sometimes, but it's very rare instances that I will start to use this. And trucks will have additional tables over here, and some of the newer stuff in the beta software will have throttle follower stuff here that I'll start to use for bleed downs. Trucks are notorious for bleed down issues, but if I have if I get everything in line, my airflow model's in line, you'd be surprised what happens when you just get your airflow model in line. That's most of people's problems. Whether you're speed density tuning it, using the math, whatever the case may be, you got to get that in line. Once this is all done, if I free rev the vehicle and let's say it comes crashing down too fast, I can come modify my torque and slowly start reducing that in an area where the bleed down becomes nice. But 99 out of 100 times, that will get me to my desired result with idle. So if you've got idle problems, those are usually why it happens.
Because I usually get the start, flare, it's nice, and then, of course, usually it's a mystery box of parts. It's not
Sure.
brings you to say, hey, make this work, and play the magic line, and,
Right.
They want some real happen. I've had to chase the external load a lot just to get a nice fallback down, rev up and drop down. And that's but I usually was chasing 15 to 20 foot-pounds. Instead of 0 to 5, so maybe that's some of my issues there.
Some cars will even go slightly negative. So like C7ZR1s for whatever reason, you start doing real radical heads cam stuff, they like to be a slightly negative, -5 to 0. So as long as I'm within that window, I usually have a pretty nice bleed down. And same thing with clutch ins and all that stuff with manual cars. But also keep in mind, if you got variable cam stuff, you also got to keep in mind you've got different cam angles. But I'm presuming it's a locked out cam or you're only advancing it, or I'm sorry, retarding it wide open. So if that's the case, you're only worried about this zero angle. But I mean, it is surprisingly easy to get Gen 5 stuff to idle. I mean, solid roller stuff, 440s, high compression stuff, they all idle really, really nice. Global B is even better. So, anybody have any questions on idle strategy? Yes, sir.
So that throttle clean is intriguing, because I've had cars, where, yeah, you're smiling,
Oh, yeah,
because you're like, this guy's had a shitty day.
Yeah,
for this.
Or
So, I've had it before where I keep pulling torque out in the idle regions, and it's saying it's idling at -70 foot-pounds of torque, and it still won't open the damn throttle.
Well, you can actually go too far. If you
Right, I'm saying I did it in steps, and
Yeah.
it just never made a difference.
Well, if that's the case, then you likely just needed a throttle clean. I've had the same instance, and the first time I experienced this, it hit me in the backside pretty good. I'm doing everything, and it's laws of averages, right? If you do 500 of these cars the same way, and then one just doesn't cooperate, you're either fighting a vacuum leak, something else is wrong, but if you go too negative, you actually induce a surge in these things, and they start doing really weird stuff.
Right.
So if you're floating around, but look at your cylinder air mass too. I can diagnose pretty much any mechanical issue just by looking at my cylinder air mass and how much air this engine is moving at idle. Your typical cam car is going to need anywhere from 10 grams a second of air to 14 to 15, and even the most radical solid roller stuff might be 18. But your cylinder air mass, you kind of fall in line with that, 0.19 for a small cam to 0.25 for a huge cam. If you're not there, and I'm idling at 14 grams a second and my trims are still positive 25, man, you got a vacuum leak, you got a mechanical problem, you got way wrong injector data. So, but all of that, as long as all of that is good, and you've done everything correctly, and you still have negative spark, try a throttle clean.
Just hitting the button, or
Just hit the
literally
button.
cleaning it?
Just literally hit the button in the scanner.
Oh,
David Griffin, David was fighting something tooth and nail, man, and that fixed his problem all day. So,
If that fixes the truck sitting at my shop, I'm gonna send you a postcard.
well, feel free.
Probably in the form of $1,000.
I mean, honestly, man, feel free to email us. We'll happily take a look at stuff for you if you've got any problems or questions, and we'll walk you through it. But
Yeah, that's been more than you, I can assure you. That's
it's many people have got bit by that. But those are kind of all the hard lessons that we've learned over the years, and try to save you guys hundreds and hundreds of hours over the course of you know, all the cars we've done and save you guys the same headaches we've had. But, I mean, it's, to me, everybody makes this way too complicated. You know, there's all kinds of stuff out there, you gotta do this, and 10 other things to get these things to idle. And then, you know, another tidbit that I'll do, you know, if you get your torque model online, your virtual torque, your airflow model, everything, and then, you know, this is another thing a lot of guys have a problem with is, you know, they go to let off the brake and this thing's just into the converter. You know, this is where I'll come into my immediate control, and I'll start to, you know, blend some of this in and reduce some of the actual torque so it smooths the spark out when I'm actually in gear on the brake. Makes it for a way better driving experience. So that aggressive spark over under stuff, that's not a real pleasurable experience in a car with a cam. And this is one of the other tables I'll use. I'll use a combination of predicted and immediate, so the blade's not jumping up and down as much, the spark's not jumping up and down. You can literally make these things with a big cam, put it in gear, and it's silky smooth. Customers don't like it because it takes all the chop out of the can.
I've had manual cars where you can clutch dump them like a diesel and they just go.
Yeah.
Should we be messing with injection timing?
Oh, 100%.
Yeah, we can go over that real quick.
So, start of injection timing, this is another one that we obviously use a lot with highly modified vehicles, especially guys stretching fuel systems to the max here. You know, you've got a couple different tables. You've obviously got your start of injection base table, and this is what everybody's pretty familiar with. So this is going to be the foundational table it's going to use on gasoline. You've got alcohol offsets that I'll show you guys. But start of injection, there's a very complex way you can look at this, or I'll try to simplify this and not, you know, bore everybody with it. But you can vastly improve the startup of one of these cars by modifying some of the injection timing in here that I've used to clean up, you know, cam cars. You can play around with this number, move it up and down. But the biggest thing guys run into is a wide open throttle. You know, there is some power to be had here too. When you start using aftermarket camshafts, you know, you'll find that stock injection timing, you know, it'll make power, it'll do what it's supposed to do. But if you play around with these numbers, I mean, a lot of it's going to be dictated by valve events in the camshaft, so I won't get into that side of it. But you can play with these numbers, you know, add 10 degrees to it, see what it does on the dyno. I've had them pick up power by just advancing the SOI a little bit with an aftermarket camshaft. You got to be very careful with this table too, because if you go too far with this, you start getting up in the 380s, 390s. I've seen guys put this crap at 410 on pump gas. It's going to look like a diesel out the tailpipe. You're literally just putting raw unburned fuel out the exhaust valve. That's not great either. So use some common sense in here, but sometimes your hand is also forced, and some of these shops are going to put stuff on the absolute ragged edge. There's a couple of people in here I know I've tuned some cars for that can relate to this, but I try never to exceed 370, 380 SOI on gas, because you're going to start dieseling this car out the back. Now there's a technical answer to this on how far you should really go, and then there's I call it the more practical application in the real world that you're going to have to use if you want something to live. And if you've got everything, in the 360, 370 SOI range, you're kind of tapping this thing out as far as fuel system goes. If you're blowing through the fuel system here, nothing's going to save you. You're plain point blank, you're out of fuel. So I look at start of injection and an injection. And the number that I have always come up with as a safety buffer for me is about 150 and an injection. You start getting much below that, you're going to start to see the pulse width climb. The car might start to misfire. You start getting 120s, 130s. Not only are you way out of gas, you're going to start to misfire. The car's going to lay over on the dyno. It's not going to make power. It's going to probably pop and bang like the 4th of July. You're going to damage injectors. You're going to do all kinds of stuff you don't want to do. At that point, you are done. You need parts. You need something, port injection. You've got to fix the fuel system. Now, if everything is still in line, I see this a lot with like Heads Can, Maggie 2650 cars. They'll make 800, 850 on pump gas. Pulse width is 4.9 milliseconds. Start of injections 360, 370. EOIs 200, 180. We're still okay. Now, if we start putting the car on E85, which a lot of shops are going to try to do, I will start to move over to this alcohol offset table. So this is a modifier based on ethanol content. So you can see this is what the factory GM file does. They pull injection timing in certain areas, they add it in other areas. But when you start getting into these higher loads, I will try to use some additional offset here to help the fuel system stay alive. Again, use some common sense here. If you start getting over 400, 390s, 400s, 405, you're pretty well done. You're going to start to lose control of the fuel. You're done.
What, your question in the back there?
Couldn't you calculate the SOI based off of camshaft events? That way you time it around and the exhaust off flows?
Yep.
That's how.
But then keep in mind latency of the injector.
Right.
So you may have to start a little earlier.
Yep. So like I said, I mean, the real, you look at valve events and you can calculate it all based on that, but these are just general ideas. And Justin, I'm sure you're aware, sometimes your hand is forced.
I'm Ed today.
What's that?
I'm Ed today.
Yeah, I agree. You know as well as anybody, sometimes you're forced to do things you don't necessarily need to do.
Sometimes you gotta go outside with it.
That's
Says
right.
you for the-
Yep. So I'll use this table when I'm on the 85 to try to get as much as I can out of the fuel system. And honestly, again, much past this, you're needing parts. Anybody else? Global B?
What you got?
According to my situation, which base file would you choose to start the tuning? It's a 2014 engine, truck engine with 2014 truck ECU, C7 intake, C7 mass sensor, C7 master flow, and C7 throttle body with manual transmission. Which the truck was automatic, but the truck was automatic 6 speed, so it has the provision to have a 2-hour speed sensor. Which base file should I start with?
I mean, that was a lot to unpack real quick, but
It depends on that throttle body and that pedal. Because if the pedal and the throttle body don't match, that's going to be could be your first issue. I would try with the truck OS first, but it's going to be a fair bit of modifications, right? Before I would start switching OSs and trying to get tricky with it.
all right, we have about 15 minutes.
Yeah, we're cruising along here. They've limited us to 1 hour. We have about 15 minutes left here. We're gonna
Move over to Global B.
go to Global B real quick and try and open up that can of worms for you guys.
These are all put place and everything like that. You get your DE cables and stuff for all, really don't calculate it all, like, if you don't do this, inside of the thing, you push the get really pissed off and start closing all bodies and stuff on the DE cables been out of whack too.
The only time I've seen so somebody had asked about max engine torque, and it usually comes from the VE side. The only time I've had the throttle close because the VE's out of whack is if somebody went ahead and put a bunch of negative numbers in the VE, and your max engine torque goes to 0. Midway through the pull, it will shut your throttle body off. That's about the only time I've ever seen that happen.
Okay, I've always just put into the assumption that, like, the SC side of things is really important when you show them to close.
I agree with that.
So I was just curious the way it was been asked and stuff in here.
I certainly agree with that. Yeah, we're getting there. So, sure.
If someone sent a picture to go rope, you just send me a text.
All right, so Global B. So this is the Global B is kind of the wave of the future now, right? This is what everybody's really struggling with: the C8s, the black wings, the trucks, and this has become a massive part of our business. We do a ton of these now, and I'll save you guys a lot of the BS and the banging their head against the wall that I had to do for the last year to figure these things out. C8s, we've got clutch unlock problems that we were dealing with, trying to understand the neural network and how all that plays a role into things. So Global B is going to be very Gen 5-esque. So it's going to be imperative that you have a decent Gen 5 background to even move into this, because if you don't have the fundamentals of Gen 5 down, you're going to have a real bad day in here. But for the most part, all of the tables that you're accustomed to using, the torque tables and all that, are going to be the same in Global B. The major difference is going to be now we have something a little bit more complex called a neural network. So all your idle tables, you kill my mic,
Tech support in the back, please.
tech support. Mike, okay. So all your idle tables and everything are going to be exactly the same as you're used to seeing. So this is a heads cam Maggie 2650 built motor, 23 Denali that I just finished up for a guy. So if we move over to our airflow tab, you're going to see a couple different things with global beam that you're not used to seeing on Gen 5. The first would be our MAF sensors backwards. That's the first thing that people usually look at and it starts freaking them out. So the MAF sensor tunes exactly like you're used to tuning it. It's just backwards. All right. Instead of idling down here and us applying throttle and the hertz goes up and airflow goes up, it goes the other direction. The MAF hertz is we're going to go down, airflow is going to go up. So it still tunes exactly the same way. The major difference here is we can no longer break out the MAF from the VE. We can break out the VE from the MAF, but we can't go the other way. So all the MAF only guys out there that just have no intention of ever battling in VEs, don't have any experience with VEs, you're going to be in trouble now because this has to be done. So if we move over to our dynamic tab, we don't have a switch point anymore. We can't tell the MAF when to turn on, when to turn off. We've got a correction factor. That's all we have. But once we move over to speed density, this is where it gets a little interesting. So now we've got Barrow this, we've got neural network this, trap ratio this, input layer this, output layer that. There's a lot of complex stuff, right? So it took me about a year to try to figure out how all this stuff intertwines with Global B. And basically, if we come over here to our edit tab, we're going to have what's called this VE neural network trainer. Now, you guys won't ever be able to see anything until you actually create a file to be trained, pay the tokens and all that stuff through HP to actually access this. But I'm going to kind of show you guys some things because I have, you can see how many times I've used the neural network trainer. I've used the hell out of it.
Looks like you did a Dodge file.
Yeah. So this, so you can see this is neural network number 5. It took me 5 revisions to get a heads cam 2650 truck in full speed density, dead on command. From driving, park throttle, idle, everything. So if we open it up, this is the finalized product of my neural network once I was complete. So it's actually very similar if you spend any time with Gen 5 virtual VE or Gen 4 virtual VE. The only difference is instead of GM VE with all these big 1,000, 2,000, 3,000, 4,000 numbers, we almost go back to a Gen 3-esque VE where it almost looks like we have 40% VE, 118, 130% VE, whatever you want to call it, but they're more normalized volumetric efficiency numbers. So, and when you do enough of these, you'll almost see patterns on how these things end up, coming together. But the difference is now it's really not a difference, is we still have different cam angle points that we need to be aware of. So, truthfully, the thing people don't want you to understand is actually locking a cam out on a neural network is easier to tune than a variable cam, because now the variable cam is going to move all over the place and affect your fueling. So, you can see this is a finalized VE table that we did in this truck, and you can see it kind of molds. And believe it or not, the factory or the neural network trainer does a stellar job of actually molding things the way they need to be. And I'll kind of show you guys a log of how this is a truck in full speed density just using the neural network. You can see, trims are within a couple percent all the way through. Go wide open throttle here. We're pretty well dead on command. And that was after 5 revisions through a neural network trainer. That's how good that thing is. You can literally make it so the whole neural network thing is, it seems complex on the surface, and it is. But once you kind of get the hang of how these things work, they are awesome to make these big radical combinations literally drive like style. But the biggest thing you need to be aware of is you need to start honing in on dynamic air. What is being weighted for. So you can see this one's in speed density. I was tuning the whole neural network because here's the thing with neural network with Global B. The MAF will not listen to you whatsoever. You can chop the MAF till you're blue in the face. You throw a cam in one of these, and your trims are way out in left field, everything's out in left field, you can chop the MAF till you're blue in the face. It will not listen to you because your neural network's too far out in left field. In order for the math to do anything as far as what you're telling it to do, the neural network has to be in line or it will not work. Now, once you dial the neural network in, you can re-enable the math, and the math will literally follow everything beautifully. It's that simple. Guys, make it simple. Yes, sir.
Is that basically leaving the math how it is?
So here's my preference on how I do it. So I'll usually fail the math. If it's a heads cam combo or something real radical, I'll fail the math and start obviously chipping away, just like your speed density tuning.
Right, just clean it up.
Yep. Clean it up, get everything in line, re-enable the math, and then what you're going to find is the dynamic error. So this is what I look at. What is it weighting, the math or the VE? Well, if you re-enable the math and you clean the math up, and obviously the trims are, because the trims are going to be way out in left field if you don't clean the math up. So, or what it's going to do is it's going to weigh the V, if the math is out in left field, it's going to weight the neural network. So now you know you need to clean it up. And once you get everything in line, the dynamic should follow both the VE and the math dead on money. Now you can make changes to your math and dial it in, and it'll follow it perfectly. The problem is tip-ins. Global B is atrocious with tip-ins.
It's no transients.
That's it. So if your VE or your neural network isn't dead nuts on the money, your transients are going to become a problem.
So it's using the neural network.
Oh yeah. Oh yeah. So this separates them in from the boards here. What's that?
That's similar to Gen 5 as well.
Gen 5, I feel, is more, yes, but if your VE is way out in left field and your math is dead on, you still don't have the massive transient problems that I'll see at neural network. Neural network, it'll go so lean, it'll like buck you through the windshield. It's that bad. But that was a year of banging my head against the wall, trying to figure out how to make all these airflow models work together correctly. But once you understand that the neural network drives this whole thing, now here's the other thing that people struggle with. So I'm gonna go through a couple things. So if we go back to the neural network, well, let me backtrack. What are the problems? I'll start talking about the problems with global B. So your naturally aspirated systems, like your trucks, your C8s, the pressure ratio stops at 1.0. Well, you're not making any boost, there's no need to go higher than that. So if you don't rescale the pressure ratio, and I found this one out the hard way, after I tuned the car, spent hours on it, got it on the dyno, didn't scale the pressure ratio, nailed the very bottom of it on the VE table, and it went piss lean, and I kept adding fuel and adding fuel and adding fuel, and it wasn't doing anything. Well, if you don't rescale the pressure ratio table, you're fighting an uphill battle. So one of the critical things you're going to need to be aware of is how much boost is this thing going to make? It's going to make 14 pounds, so I need to go to a 2.0 pressure ratio. So you've got to know this and give yourself some leeway, because if you have to go back and retune this thing, it's going to shift your whole table and you're starting over again. Now the problem that I've run into on the naturally aspirated stuff is your math curve caps out at 511 grams per second. So if you have a combo that's going to exceed that, you're almost either forced to do it speed density, because I have an unlimited amount of airflow model at this point, or DSX makes MAF extenders and all this stuff, but I'll usually just go right to speed density and just use the neural network for everything. It's phenomenally how easy these things are once you understand this. Of course. I do meth cars with these things. I've done twin turbo trucks with meth. I've done port injection with them. They tune just like you would anything else once you understand the neural network.
Not to kind of go off track, but have you played with the DSX?
The Atlas?
Injections? The Atlas, yeah.
Not directly, but through others, in the industry that we work with. It's genius what you do with it. You're not having to hack the torque model up anymore so all the guys that are kind of on the fence or tuners that weren't real comfortable, using aftermarket, Holler systems and getting the torque model back in line, that system completely eliminates needing to do that. Yeah. Questions on neural networks over? Yes, sir.
Have you done the black wings where you run out of the math?
The black wings won't, so I'm happy you touched on that. So, and truth be told, I don't know why. And this is one of the things I'm trying to work on right now. So if you look at a black wing, okay, now obviously they have a boosted operating system from the factory. The math will go to 1,000 plus grams per second, but it's like a C701. You look at a C701 math curve, there's an alternative calculation that's happening, because a C701 at the very top on a stock file is 150 grams a second. Well, when you log it, that's not true. You're moving 800, 900, 1,000. The
black wings, the SYVs, and all the LT4 stuff are the exact same way. You look at the math point that you're at wide open throttle, it might say 280 grams a second, but you're really moving 900, 800.
Way more.
So you have an infinite amount of math left in the neural network black wings or LT4 stuff. The trucks and CH do not.
Do you know if anybody's tried to break that code out and apply it?
There is somebody that's broken that code out, and there is somebody that knows how to do it, and I've been trying to get the information out of them, and nobody will give it to
Can
me.
you tell me who being a gatekeeper?
Yeah. Yeah.
A lot of money in
So in my not so spare time, I'm trying to figure out what that is.
Yeah.
So, but everything else, I mean, there are some quirks with Global B. I can touch on, you know, everybody has questions on C8 stuff. How do I keep the clutch unlocks from happening and all that good stuff. C8s have a problem when you start adding a significant amount of power per stop. If your predicted torque gets too high, you'll start unlocking clutches. So you've got to be very cautious with Global B on how much you request. It's not like drag only Gen 5 stuff where you can jack a driver demand through, you know, table through the roof and it's going to work. That's not going to fly on Global B anymore. So you've got to be significantly more precise in how you use the airflow model and torque model with getting these things to keep the throttle open and cooperate.
We've got about 4 minutes left here, so I'll put this slide up. We do teach a complete course on this, and it covers all this in much further detail, how to use the neural network, the 10-step process that's included with that. Thank you, Brandon, for the quick tutorial. I know hopefully you guys got something out of that. This is some of our PRI stuff. Our Global B class is on our site. It is locked because we kind of only let people buy it who've been through our Gen 5 stuff because it's just an add-on course. The Global B course that we have simply follows the trace. It picks up right where our LT5 course falls off. And if you just dump somebody in the Global B course, obviously you would get an infinite amount of emails and tech support would be through the roof. So we want to get you guys with the base concepts first. I know a bunch of you guys already, even if you know 90% of this, you're going to pick up something in that course, I can guarantee it. And you'll definitely pick something up on the transmission course. We sell a ton of those transmission courses. It's probably one of our biggest sellers is transmission courses. But I know you guys have been around the block, but if you are barely new to tuning, you just came here to kind of check it out. We do have the Gen 3, Gen 4 LSF subscription program now. It's $34 a month, which is insanely cheap. It gives you 8 of our courses, pretty much all of our LSX content. We're basically throwing it out there to the market for free, and you get access to our internal group for all the guys in our school to ask questions and start the process. It takes you from downloading software to doing twin turbo cars and 6L90, 80, you name it. It's a phenomenal value for getting started. So we've got just a couple of quick minutes left here. If you guys have any other questions, we'll be in the booth all day. If you want to swing by and come see us, and obviously check us out on the net. Go ahead, buddy.
I guess 2 big questions. One, so I'm guessing there is, but there's a definitive way to determine your torque tables then? Not just like the touchy feel like, oh, sometimes you gotta raise it, sometimes you gotta lower it. Like I'm talking in the driving area, it's not idle.
So
You'll have a method in the course.
So there's methods, and here's the other thing. We urge you, if there's something that's not clear, we are the easiest people to reach out to. I'll happily spend one-on-one time with you and walk you through anything you're not totally clear on. But here's the other thing. Don't overthink it. I see a lot of guys get in their own way, and they end up making a ton of mistakes and causing more issues than they're fixing. You know, truth be told, unless you're, you know, the biggest issues you're going to run into are, so the biggest thing with torque-based ECUs is getting the pedal, the TPS to follow your pedal command, 1-to-1. That's my biggest gripe with drivability, right? When you strap blowers on trucks, you know, they snap the throttle wide open, so, you know, you got to really numb down some tables. Those are kind of more of the one-off stuff, and if you have questions on that, on getting all your torque tables in line, driver demand, torque, and all that, I'm happy to spend some more time with you on that, but we do cover a good portion of that in the course.
And if you guys have if you can find something in the course that we feel needs to be added, we simply film it and add it. And that's the difference between our stuff, is we are constantly adding, modifying, cleaning up, and changing our content on every single course that we teach. So if we find something that's better, faster, or needs to be taught, we just add it, and you immediately have access to it. So we're constantly taking feedback. We love feedback, and we love to expand our course and make it as good as it possibly can be. Well, guys, we're going to call it. It's time's up. We'll be in the booth. Any questions? Let us know.